This is your review for your test. Good luck tomorrow. In problems number 1 through 7, you're looking for a keyword. You're not responsible for actually graphing the problem. So you're looking for something in the problem that is a keyword as to what the solution is. So in problem number 1, the fact that the lines are parallel proves to me that the lines are never going to intersect, so there will be no solution. On number 2, when this person did the math, they came up with 0 equals 0, which is a true solution. And since that's true, that means I'm going to have infinitely many solutions. On problem number 3, they got x equals 3. When I get an x equals 3, that means that I'll be able to find a y, and I'll have 1 point. So my answer will be a 1 solution. Number 4, these lines intersect. That means they're going to cross at 1 point. So 1 solution. Number 5, this answer, after they've done their work, is false. So that means they will never cross and there will be no solution. On number 6, -3 is always equal to -3, and that's true. Anytime I get true, it's infinitely many solutions. And on number 7, since the lines coincide, they are identical. That means I'm going to have the same line twice. That means I'm going to have infinitely many solutions. On number 8, they're asking me to solve this system by graphing. So since this is in standard form, I'm going to cover. So I'm going to cover the x. I'm going to get y equals 3. And when I cover the y, I'm going to get x equals 3. So x equals 3, y equals 3 on the red line. Here's my red line. On the blue line, I'm going to cover as well because it's standard form. Y equals 1, which is here. And if I cover the y, since x is negative, it's going to make my 1 turn negative. So x is equal to -1. That's here. And then I connect my points. And now I have 2 lines, a red one and a blue one. These two lines are intersecting at 1 point, which is 1, 2, and that's the solution to my problem. On number 9, I'm going to follow the same process as number 8, basically covering, solving, same thing here. Or you could solve for the y on both sides. And in this case, they have the same slope, so I can tell they're parallel. So, or I could graph each one using the standard form, and I will find out that the lines will not intersect, so that means there will be no solution. Okay, on number 10 you have a word problem. On the blue part that's underlined, you can see that you can make an equation, y equals 8x plus 5, because Jill is earning $8, which is the rate, which is your slope, and 5 is your y-intercept. On the purple, you can see the same thing, except that instead of y, we have 2y, so 2y. And she's getting paid $16 per hour plus a $10 for your y-intercept. So after you're done graphing, we find out that the lines are coinciding. So you have your blue line underneath your green line. And in this case, that means that the 2 babysitters will always be charging the same amount. So it really won't matter which babysitter you hire. On number 11, it's asking for me to solve using substitution. So since I already have a y by itself on one side, x minus 2, I'm going to take the x minus 2 and substitute it in for this y here, creating a new equation. X minus 2 equals 4x plus 1. I'm going to get rid of the x on this side by subtracting it on both sides, giving me 3x here. I'm going to subtract the 1 on both sides. I'm going to get -3. That means I'm going to get an x equals to -1. I'm going to bring this -1 back to my original problem here and substitute it for the x, giving me -1 and -2. You owe me 1, you owe me 2, now you owe me 3. So the solution is -1, -3. On number 12, it's a little more complicated because nothing is alone except for this x here. If I move the 2y to the other side, it's going to turn into a negative 2y. So I'm going to end up with this. And I'm going to take that and substitute that into one of my original problems, which in this case we're deciding to substitute into the top one. And the x here will turn into negative 2y minus 1. You see it right here. Now I'm going to distribute the 2, giving me negative 4y minus 2 plus 3y equals 0. Negative 4y and 3y is negative 1y. I'm going to add the 2 on both sides. The negative 1y divided on both sides will give me a negative 2. Now I found my y. But I still need to go back and substitute this negative 2 back into this equation here. And it goes in this spot. And after I'm done doing my work, I find out that x is equal to 3. So the solution of this problem is the x is 3 and the y is negative 2. On problem number 13, we have another word problem. In the green section here, you find out that Jim is working 40 hours at his job last week. So they're not telling us that there's an x and a y, but I know that he has 2 jobs. So one of the jobs is x, the second job is y. If I add up the hours from both, I get 40 hours altogether. In the purple, they're actually telling me how much he's earning at each job. So in our first job, he's earning $20 per hour. And in the second job, he's earning $18 per hour. And they're telling you how much money he's making. So this equation has to do with money. The first one has to do with counting the number of hours. Since they're not telling me how to solve this problem, I'm just going to use elimination. So I find that if this was a negative 20, I could multiply everything by negative 20 and the x's would cancel. And here's what we have here. The x's are canceling. Now since I multiply negative 20 times y, I got negative 20y. But if I add that to 18, I end up with negative 2y. And same thing with the negative 20 times the 40. If I multiplied it, I get negative 800. And if I add it to 770, I get negative 30. So I have this new equation here. I have to divide both sides by negative 2. That means I find out that Jim is working 15 hours at his second job. But I still haven't found out how many hours he's working at his first job. So I'm going to need to substitute the 15 back into this green equation, bringing it here. And that's what it will look like. X plus 15 equals 40. Subtract the 15. I find out that Jim is working 25 hours at his first job and 15 hours at his weekend job. This concludes page 1. 14, I automatically find out that the y's cancel, leaving me with 3x equals 15, x is 5. I'm going to take that and substitute it back into one of the equations. I chose the first one, so I'm putting the x as the 5 here. Solve for y, and y equals negative 1. My solution is 5, negative 1. On number 15, nothing is canceling, so I'm going to end up choosing the y here, and I'm going to multiply everything by negative 1 so that I can cancel. This y here will change into a negative y, but the x also changes to a negative, and the negative 10 changes to a positive 10. That'll cause the y's to cancel. X will be 2. I'm going to take that and substitute it back into one of my original equations. I'm choosing the first one. So this x will go here. There it is. 2 plus y equals negative 10. If I finish solving, y will be negative 12. So my solution is 2, negative 12. Number 16 is very similar to the one that we did earlier. A man and his 3 children spent $40 to attend a show. So the man by himself is X, but he has 3 children, and the children is Y. And he's spending $40 for all of them. A second family has 3 children here, and they have 2 parents, 2 adults. So I'm setting up that equation, and I find out that nothing cancels. So if I multiply this by a negative 2 on all of them, I'll be able to cancel my x's. When I finish adding them together, I end up with this equation here. And if I solve it, I find out that for children, we're paying $9 each. Number 17. They want us to solve algebraically, and then they want us to check our answer by graphing. Algebraically means that you're just using one of the methods that you don't graph, so elimination or substitution. In this case, we're using elimination. We're multiplying here by a -3, which will change this to a +3. If I multiply, I get -15, +3, and -24. Please don't forget to multiply the second part of the equation. Everything must be multiplied by the same number. So that gives me these two equations here. The y's cancel, just like I wanted. I end up with -11x equals -33. If I divide by -11 on both sides, I get x equals 3. Now I need to substitute that back in, so I'm choosing to substitute back into the second equation here. The x will be a 3 here, so that'll turn into 15 minus y equals to 8. Subtract the 15 on both sides, and I find out that -y equals -7. If I divide by -1, it'll cancel this negative, and what I do to one side, I must do to the other. So that means the y equals 7 because the two negatives become a positive. And so my answer becomes x equals 3, y equals 7. Now I have to graph in order to verify my answer. So if you use standard form and cover solve, you can graph the green line with your y-intercept being at 3, which is here, and your x-intercept being at -1.2, which is here. And same thing with your blue line, and you find out that they cross exactly at 3,7, which is somewhere in between the 2 and the 4. You have to be careful with graphs because sometimes they go by 2s, so careful with that. Okay, on number 18, we're going to multiply by -4 in order to make this a 12. A -12, so that it will cancel. So after multiplying all of the equation by -4, you find these two equations and you solve for y equals 2. Plug that back into one of your other equations, and so I chose the first one. Here it is. And once you solve, you get x equals 5/3. 5/3 is the first term, and y, the 2, is the second number in your point. After graphing, you find out that it's true that these two lines cross at 5/3, 2. Number 19, another word problem. 10 bagels, which is x, and 4 muffins, which is y, cost $13. 5 bagels and 8 muffins cost $14. I'm going to multiply this entire equation by -2 so that my 10 will cancel. Here we go, 10x will cancel. And I find out that my muffins cost $1.25 because my muffins came second. Then I'm going to take that number and substitute it back into the red equation here, where the y is $1.25. Multiplied it with the 4, got a 5. So finished solving for x. I find out that x is 80 cents. And x was bagels, so I find out that I'm paying 80 cents a bagel. Number 20 is very similar to the problems we've been doing, so I'm going to skip that. Number 21 is slightly different. So Angel has a total of 97 dimes and nickels. Now that's when you're counting your coins. So that's going to be our first equation. So I have dimes and I have nickels, and I'm adding them together. They're just coins, and I find out that I have 97 coins. So I pour out a jar of coins and I'm counting them, separating them. That's all I'm doing there. In the second equation, we're actually attaching money. So you can see that my dimes are worth 10 cents and my nickels are worth 5 cents each, and together I have a certain amount of money. So here you can see that there's a dollar sign, so I have $8.35. So I'm going to multiply by -0.5 on all of them so that I can cancel the nickels. Since I only need to know the dimes, that means I don't need the nickels in my equation anymore. I want them gone. So after I'm done with the nickels and canceling them, I find out that I have 0.05 dimes equals $3.50. After dividing on the calculator, I find out that I had 70 dimes. And that's all they were asking me for, is the dimes. That concludes page 2. Okay, on problem number 22, this is a different method of doing this type of problem. Just remember that when we did it in class, I showed you another method where you go backwards and you find the y-intercept for each one, and then you can quickly give me the equation. In this problem here, you have 2 points, which is 1 comma 58 and another point 2 comma 66. And so you find the slope, so you do y 66, take away the other y, which is 58 on top, that's your rise, over your run, which is the 2, take away the 1 at the beginning, and I end up with 8 divided by 1, which is 8. That's my slope. My slope goes here in the point slope formula. You use one of these points, either this one or the second one, to fill in the point slope. So y, take away 58 because 58 is the y, and x minus 1 because 1 is the x. Distribute the 8, add the 58, and you end up with an equation of y equals 8x plus 50. So that was the part for Sunnyside Campground. You can do the same thing for Green Mountain Campground, which is number 23. On number 24, 25, and 26, they're very similar. So I'm probably going to only do number 24 and number 26. Or I'll actually do number 24 and number 25. So, okay, they gave you a point, which is an x is 2, and the y is negative 2. So everywhere you see an x, you're going to fill it in with the 2. So I see an x here, and I see an x there. So that'll turn into 2, but that one will turn into a negative 2. And the y is a negative 2, so everywhere you see a y, you're just going to substitute in the negative 2. So here's a y, here's a y. You'll see a negative 2, a negative 2. And the x was 2. And here, if we put negative 2 plus 1, you'd get negative 1. So in our first problem, you have negative 2 is greater than negative 2 plus 1, which is negative 2 is greater than negative 1, which negative 2 is not greater than negative 1. It's actually smaller. In the top equation, negative 2 is less than 2 minus 3, which is negative 2 less than negative 1. That's actually true. Negative 2 is actually smaller. It's to the left on the number line of negative 1. So here, because this part of the problem did not work, my answer is no. That means that 2 comma negative 2 is not a solution to this system. Now let's try one that was a solution. So same thing, 2 is x, y is 5. Go ahead and substitute everywhere you see an x, everywhere you see a y. On the first one, you see it checks out. 5 is actually greater than or equal to 4. It doesn't have to be equal to each other, but it is greater. So as long as one part is satisfied, it should be fine. Okay, 5 is greater than 4, so that one also checks out because 5 is always greater than 4. Since they both are checking out, my answer is yes. Okay, on number 27 and on number 28, these are systems of linear inequalities, which means they involve shading. So this is in slope-intercept form, y equals mx plus b. Use your b, use your m to graph a second point. Graph your pink line, which is solid because it has the bar. And it's shading down, so you can see all the pink going down because it's less than. On the second inequality, you have plus 0, so my intercept is 0. But then I'm going to move down to right 1. And this is also a solid line because it has a bar at the bottom. But this one's shading upwards because it's greater than. So you see all the blue shading upwards. Now, my solution is where the purple part happens because blue and pink is purple. So it turns into purple. So this purple area is my answer. So sample answers would be 2, 1, 1, 2. Some more sample answers would be -1, -2, and -1, 3. These would not work because they're not falling within the purple area. Same thing goes for number 28. The only thing that might scare you is the 1/2 here. We start at 1, go up 1, right 2, up 1, right 2. That creates this green line, which is solid because of this bar, but it's less than. And we're shading down. On the second inequality, it's in standard form. So if you cover your x, y is 3. Excuse me, right here, y is equal to 3. And if you cover the y, x is also 3. So that's here. But this is not solid because it does not have an equals to the problem. So it's going to be a dashed line. But it is less than, since I don't have to switch because the y is positive. So it'll be shading down. So the solutions are in this little area here only. This is not an answer, and this is not an answer. Sample solutions would be 0, -1, which is in this spot, 1, -2, which is in this spot, and bad answers or non-solutions would be 4, 5, which is here, and -3, 2, which is in this purple, but it's not in this shaded area. Okay, on number 29, 4 times 5 is 20, and if you divide by 5, you get 4. 4 times 10 is 40, and if you divide by 5, you get 8. That's where the distributive property ends. Then you copy down the -6x, and you bring down the 14. These two are already on the same side. You combine them. 4 take away 6 is -2x, plus an 8 equals to 14. Subtract the 8 on both sides, -2x equals 6. Divide by -2 on both sides, x is equal to -3. Done.
Much in there.
Okay, and this one, distribute the 3 and combine like terms. Finish solving, but when we get to this part, if we're dividing by a negative, the inequality needs to change directions. So in this case, it changed directions. And -35 doesn't divide evenly by 35. You're going to have a decimal. On C, the 6x and the 2x are on different sides of the equation. So I'm going to move the 2x to this side, but I need to change signs. So 6 minus 2 becomes 4x. Same thing with the 4. I'm going to move it with the -7, but it needs to change signs. So it's going to become -4, -4. That becomes -11. Divide by 4. And this doesn't have an inequality, so there's no change in signs. Excuse me, directions. And -4 divided by 4, also you're not going to get an even number, so you're going to get a decimal. That concludes page 3. Number 30, part D is repetitive. It's similar to part A. 30 is repetitive because we've done that one like it already. But the only difference is that she wants to make at least 80. So that means she wants to make more than or equal to 80, which means that it'll be greater than or equal to 80. Also, on the blue part here, it means they're saying here that he can work no more than 12 hours a week. That means he could work less than 12 or equal to 12, but he cannot work more than 12. So that means whatever he is working in hours, it has to be less than or equal to 12. Pretty much that's the only difference. Also, it's an inequality, so that means you have to shade. And whenever we're working with the real life type of problem, you want to stay in the first quadrant. So that means after you found your x and your y intercepts and you've graphed your lines, both of them are solid lines because they both have bars. But if you notice, the blue line goes down, the red line goes up. So my answer is not here, my answer is not here, my answer is not where there's white spots, but the answer is where they're both overlapping, which means that my answers would be in this little shaded area here. Okay, so the shaded region from both. A sample answer to this would be that a babysitter can work 8 hours of babysitting and then 2 hours of gardening, and it will satisfy the system. On number 31, you can tell that this is not an inequality because the office manager is actually spending the entire amount of money, and you can tell that the cost was exactly $515. So there is no inequality because I'm not doing less than or greater than. It's just exactly that amount. So other than that, there's not much difference. You just have to try and cancel one of your variables and get your answer for desk and get your answer for chair. On number 32, you can tell that the job pays $25 an hour and an internship pays $10 an hour. The student does not want to work more than 15 hours a week. That means this is an inequality. They're telling you that he cannot work more than 15. But he can work less than 15 or equal to 15, which is in this blue section here, you can tell that it's less than or equal to. On the green part here, it says that he has to earn at least $250, which means that he can earn more than $250 or exactly $250. So that makes it greater than or equal to. After graphing, you can find where they overlap. So they're overlapping in this little section here. The second part of the problem is asking, can he work 5 hours at his job and 10 hours at his internship? So if you look on the graph, 5 hours at his job and 10 hours at his internship is not in the shaded area. It's somewhere right here in the white spot. And we're looking for answers that are in this spot here where they're overlapping. And so the answer would be no. It's not in the shaded region. Okay, so on number 33, before you're even graphing, you can tell if the lines are going to be coinciding or if they're going to be parallel. So right here, these could be possibly parallel because they have the same slope. But if they have the same y-intercept, that means they're not parallel. They're going to be exactly the same line. So you can see there's a blue line and a green line. That means I'm going to have infinite solutions. In part B, I'm having the same thing happen. They have the same slope, but they also have the same y-intercept. So that means they're coinciding again. That means I have infinite solutions. If I would have had same slope but different y-intercepts, I would have had two lines that are parallel. So I would have seen one line, and I would have seen a separate line when I graphed it, and that would have been no solution. That was the end of page 4. On number 34, it's time for your calculator. So if you remember correctly, you press stats, you press enter, and then you're going to type in all of this data here. And then you're going to press stat, move over to the right, calculate, and hit enter many times until you get this list. Now remember, the mean comes up, the median comes up, the mode is the number that you see them happening the most. So in this case, we see 60 the most. The range is the largest number. Subtract the smaller number and you'll get your range. For the IQR, you're going to take your Q3, take away your Q1, and these are not found on the calculator. The Q3 and the Q1 are, but the IQR is not. You're going to need to actually subtract them. And once I subtract them, I get 30. Do the same thing with set B. Do the same thing with number 35. On number 36, they want a line that's perpendicular to this line. So we're going to take the slope, which is 1/4, and we're going to give the reciprocal and change the sign. So that means my m should be -4. I also have a point, which is -2, 1, and I'm going to substitute that all into point slope, which is y minus 1. Don't forget to change the sign on this point. Y minus 1 equals my slope, parentheses, x plus 2, and it's plus 2 because the x is a negative, so it becomes a positive. This y was a positive, became a negative. Solve the equation for y equals negative 4x minus 7. You should notice that these slopes are not the same. Neither are the y-intercepts. On B, in order to start this problem, we first need to solve for y. So that means the x needs to move to the other side. These cannot be added together because they're different. So I have negative x minus 18. I divide everything by 3. I end up with this equation, negative 1 over 3 x minus 6, because 18 divided by 3 is 6. I now have a slope, but I need to do the reciprocal, and I need to change the sign. So that means it'll be 3 over 1, not 1 over 3, and it'll become positive. So my slope is 3. My point that they gave me is negative 2 comma 5. I'm going to substitute that into the point slope, changing the signs. Y minus 5 equals 3, x plus 2. Solve for y. My equation is y equals 3x plus 11. For part C and D, these are parallel. So after solving for y, I end up seeing that my slope is negative 3. So I move the 6x over. I divided everything by 2 and ended up with y equals negative 3x plus 2. My slope is negative 3. When my lines are parallel, the slopes are the same. So that means my new slope is going to still be the same as this one, which is negative 3. The point they gave me is 1 comma negative 3. I'm going to substitute all of that into the point slope formula. Y plus 3, changing the sign, equals my slope, which is this one. X minus 1, because it was a positive, it became a minus. Distribute the 3, negative 3, and I subtract the 3 on both sides, and I end up with y equals negative 3x plus 0, which you can just leave as y equals negative 3x. Problem D. I need to solve for y on this equation because it's not isolated. I move the 9x as a negative to the other side. These cannot be added together. This 12 does not have an x. The negative 9 does have an x. They need to be written separately. I put the x first. Then I'm going to divide by negative 3 on both sides. This will cancel, leaving me with y. Negative 9 divided by negative 3, a negative divided by a negative is a positive, and 9 divided by 3 is 3 with an x. A positive divided by a negative is a negative, and 12 divided by 3 is 4. Now I have my equation solved for y, and I find my slope is 3. Since they're asking me for a line parallel, I'm going to have the same slope as this line. My point that they gave me is negative 2 comma negative 4. When I put those into the point slope, both of them are going to change into positives. The 3 goes in this spot. The 4 goes over here, becomes a positive. The negative 2 goes here, becomes a positive. Distribute your 3, 3x plus 6. Subtract your 4, and here's your new equation, y equals 3x plus 2. That's the end of your review. I hope this helps. I'll see you tomorrow, and good luck on your test.